All right, so last time we were working on this on classes. We designed this class for a book structure that basically allows you to encapsulate multiple pieces of data together to group them into one logical unit so that you don't have 9 pieces of data sitting out there in 9 different arrays or 9 different variables. You can also protect that data, as we saw, by making them all private. That allows you to control access from the outside world, that you can't just set the title to null if you want to. And then we also grouped functionality that operates on that data within the same unit. For now, that simply meant the constructors, that is, the way that you can construct a book by setting each one of these variables to the provided input here. The toString method that allows you to output it to a string in a human readable format, and then a whole bunch of series of getters if you actually need each one of those pieces of data. But by only doing this getters and not doing choosing not to do the setters, we've made our object here, our book class, immutable. You cannot change it once it's been created. All right, so continuing from there, remember that I said I was going to bring in old code that we already previously worked on, and that's what I did here. that code that was used to load up book data from that CSV file, that's now in one function, right? Now remember that if you're going to write functions, non-trivial functions, a trivial function would be like the main, you need to document it. And so what happens here, what are we doing in this function? Well, what are we doing in this method? Loads and returns book data from the given file, right? File. And I can even put that into code there, right? Remember that you can use HTML within your documentation strings here, and it will format it as HTML when you hover over it. Let's walk through that just as a review. Remember that we open up a file for reading here. Actually, that doesn't open the file. The scanner opens the file. And we need to read it line by line and process each line. I created a list here of books. Initially, it's going to be empty. And as we process each one of these pieces of data, we get the next line. By the way, remember that we are burning the first line here because that tells us how many records there are. And then we get the next line. And then we split that up into tokens upon using a comma to split them up. That's because it's comma-separated values, CSV files. And then for each one of these, we convert it to the proper type of variable. For example, integer, that's integer, parse int. Double, it's going to be double, parse double, et cetera, et cetera. And I briefly talked about how to use local date. You don't have a constructor, so you can't call a new local date or something like that. And so what I've done here is I've called another method called parse. It'll take that string that looks like 128 26, right? And then it'll, according to this format up here. You can read the documentation if you want, but this is the standard American formatting here, where it's month, day, and then year. That's not the proper ISO 8601 formatting, which is the default, but you can create a formatter for whatever format you're expecting. And that's what I did here. I'm creating a local date from that formatting. Finally, I create a new book by handing off all those pieces of data over to my constructor, adding the book to my list, and then ultimately I return my books at to the main that's calling this. Remember, this is a static function, so you need to use the class name, dot, and then the function name or the method name here. And so bookdata.load bookdata. Now, arguably, this load book data, that's doing book stuff, right? So why didn't I put it over here into the book class, right? Well, it's not a book thing, it is a books thing, right? That's why I'm putting it over here into the book demo, which I'll ultimately maybe rename as book utils or something like that. And so sometimes it is okay to put related code in a different file. It's kind of like that, it's things that you can argue about. Maybe it does belong in the book class. Maybe it belongs over in the utils class, right? Where does this actually belong? And then you can decide based on your design choices, right? But definitely the book stuff belongs in the book class. And then I print it out here. All right, and let's just make sure that we've got all of our books here. And this is a different formatting than I had before. It's the title, and then it's all aligned nicely to the left. By, and then the author, and those are all nicely aligned so that we can see it in a table kind of format. The year, and then the rating here, because I'm going to be asking questions about what's the oldest book, what's the newest book, what's the best book, etc. Right? How did I end up achieving that? Well, let's take a look at the toString method again, a little closer. String.format is a way that you can use printf style formatting, but then instead of printing it to the output in the console down here, it actually formats it into a string, and then you can do whatever you want with that string. And so I'm returning the string.format. Otherwise, it's the exact same formatting as you would have with a printf style or in Python f strings, right? And then I format format all the data that I actually want to output there. Okay. So now that my book class is pretty much complete and I've loaded up all my data, I can start now asking questions like, what's the oldest book that I've read? Right? Now, if I were just to do this naively, what I could do is I could say let's create a book, B, is equal to the oldest book. Let's call it oldest book. Right, there we go. And let's go ahead and assume that the first book, books.gets of 0, let's assume that that's the oldest book. Then I'm going to go through the rest of the books for book B in the collection books. Right? If I ever find something that's older, that is, if b.getYear, now you can see the utility of those getters, right? I can get individual pieces of data. If that is less than oldest book dot get year, there we go, then I found a book that is even older, and I would update my oldest book. Oldest book is equal to B, right? And then at the very end, I can report the oldest book. System.out.println oldest book is going to be, and then I'll just go ahead and concatenate it here. Because I wrote that toString method, it'll take care of the concatenation and the formatting for me. There we go. We want the oldest book there. So what indeed is the oldest book here? Looks like The Republic by Plato in -400. Right? Well, what is -400? That's 400 BCE, right? That worked, right? But it's not very satisfying because I had to write a lot of code, right? And not only that, but if I want to answer the question of what's the newest book, what am I going to have to do? Copy paste this entire thing and change all the oldest to newest, and also change the sign here to greater than, right? I don't want to do that, right? Instead, can somebody suggest a much easier solution? Remember, what did we just cover before classes? Searching and sorting, right? So if I were to sort all the books, would I have both of my answers at once? Sorted according to year, right? Where the oldest book is now at the top, the newest book is now down at the bottom, right? So I like that solution a lot better, okay? So let's go ahead and sort them first by year, okay? That means that I need a comparator. And do you remember how we did comparators for integers or for strings, comparator? Now I'm going to do comparator, there we go. Now I need one not for integers or strings, but for books, right? And this will be a comparator for books by year is what I'll call this, okay? And it's a new comparator, home row, comparator, right? And I need to create a method in here. First of all, I need to import these. These are going to be part of the Java util library. And then I can allow it to generate some of the code for me, right? Where, come on, click. There we go. All right. Where it takes two books. I don't like, the default here is to O1 and O2. I'll just call it A and B. That's a lot better, right? I mean, they're still not very descriptive. You could call it B1 and B2 or book 1 and book 2. Just keep it simple, A and B, right? Now, this comparator is going to have the same contract as before, that it's going to return something negative, positive, or 0, depending on the relative ordering of the books. So all I need to do here is compare the year, right? If A dot get year, get year, right, is less than B dot get year, then I'll return something negative, right? Return -1. Again, don't get fancy. Don't report to, like, use 42 or some other random number out there. Just use zeros, ones, right, and -1s. All right, now is that in order? Think about this: 1900 versus 2000, right? That's in ascending order, right? Okay. So where will the oldest book be? It'll be at the top. Right? And then the newest book will be down here at the bottom, if I go in that order. Else if, now I need the rest of this. A.getYear is greater than B.getYear, then that means that they are out of order. Oops. Return something positive. And again, don't get fancy. Otherwise, the only other possibility here is that they were published in the same year, 2025 and 2025. So let's go ahead and return 0. And now let's go ahead and sort them. Collections.sort my books using this comparator up here. And by the way, if you don't provide a comparator, then it won't compile. The built-in types like string, integer, double, it knows how to do those because those things are already comparable. We might look at that later on. But a book is a user-defined class. This is something that I just defined. It doesn't know how to sort those things. You have to build a comparator and then hand it that comparator in order for it to determine how to sort them and how to order them. Right? Up here, I'm going to go ahead and move this printing down here for now. so that we can see that it actually worked. Let me go ahead and run this again. And where's Plato's Republic? Right at the top, -400. Then we've got the Prince, the Romeo and Juliet, Gulliver's Travels, etc., all old classics. What's at the very bottom there? The newest book that I've read is Polybus or Polybius or whatever it is, right? Published in 2025. Now, do I have to worry about, writing my own loop to iterate through it and find what I'm looking for? No. All I have to do is say, say book, oldest book is equal to books.get. Where's that oldest book? It's right at the beginning. Where's the newest book? Equals books.get, and it's not the 0. Where is it going to be? So if I have 50 books here, what is the index of the last book? 49. How do I get the index of the last book here? Books.size, remember, tells me that there are 50 books in there. Maybe then you need to subtract by 1 because it always starts at 0. And go ahead and get rid of this so that I'm not printing everything out here. System.out.println oldest is going to be plus oldest book. All right, misspelled that, but that's okay. I'll come back and fix it. And then newest book, oldest book, and newest. All right, I'm not going to have to print them all out. All I have to do is be confident in my code and see that it's the Republic and Polybius, whatever. All right, let's come down and start answering these other questions here. What is the best or the worst book that I've read? Right? In other words, according to these ratings over here, okay? What would you do now that we've gone through that exercise? I would sort them by the rating, right? I'm going to do it a little bit differently here, though. I'm going to have a little bit more compact syntax. Comparator for books, CMP by rating, right? Comparing it by rating is equal to, now do you remember that shortened syntax that I gave you for integers and strings? Comparator dot comparing, right? Now this comparing, that takes a new type of syntax. I don't know if we covered it before, but we'll do it here. Book, get rating. Here's another reason why you want to define those comparators. Because all this is doing is creating a comparator that compares books by their rating. There should be 2 colons there. What this is a method selection operator. In the book class, use this method, get rating, in order to order stuff. And then it does it automatically for me. I don't have to do anything other than that. Right? Book, best book, is equal to, or I guess I need to sort them, right? First, collections.sort, books, and then CMP by, where are we? CMP by rating, right? And the best book now is going to be where? At the top or at the bottom? Let's just assume that it's at the top, right? Books.get 0, right? And then book, worst book is equal to books dot, and then there is a method here called get last, right? So you can do it by index like I did before, or you can do it by using these other methods that are built into the list library. And by the way, there is a get first, right? Okay, that's a little bit better syntax, right? Or it's a little bit shorter, more human readable is what I should say. Maybe not best, but more human readable. And so what's the best and what's the worst? Right? And so here's the best and here's the worst. Was I right? Is the worst book at the bottom and is the best book at the top? All right. So here's the best, a rating of 3, right? Twice Upon a Time. And the worst is Wise Man's Fear, 4.55. Does that sound right? Nope. So what was wrong with my comparator here? Get rating, that's the natural ordering of doubles of numbers is going to be in ascending order. So I could switch these around first and last, or what could I do to my comparator to make it right? Reverse it. Right? Remember, you can chain these things together, right? Okay, so let's go ahead and run that. There we go. Now it's switched around. Right? So these were pretty big questions when I started, right? What were, if I just started from the CSV file here, right? then that seems kind of daunting. There's a lot of data in there, just like your assignment. There's a lot of data in these huge files, right? How am I ever going to possibly process all this data? Well, the first step is to model the data in a class. Once you've got that, and once you've got a way to search and sort through things, your tasks become a hell of a lot easier, right? So maybe take that as a design hint about what you should be doing on that third exercise. What about all books by Frank Herbert? Okay. All right. And who is what author? What is the author whom I've read the most here? Right. In fact, let's go. I'm going to change this to find a book by Frank Herbert. Right. So we called it searching and sorting. Well, searching came first, right? So I want to find a book by Frank Herbert. How do I go about doing that? What if I were to sort them by author first? Right? How could I exploit that structure that now it's all sorted by author? Well, I could start at the top and then keep going until I find Frank Herbert there. What's a better way of doing that, though? I mean, then why do I even bother sorting it if I'm just going to go through every record anyway, right? So find a book by Frank Herbert. Sort by author. Then what can I use to search for him? If it's already ordered, if it's already sorted. I could do linear search and go through the entire thing, but what's more efficient? Yeah, binary search for Frank, right? ... Okay. All right, let's sort it by the author first. Comparator book CMP by author is equal to comparator. I'm going to use this more compact syntax. Comparing book last name. Or get last name, I think it was. Get last name. Name. There we go. Now, is that guaranteed to order them all by author? Actually, I don't know if I've got any books here by him, but there are actually two Herberts out there. Frank Herbert and his son, Brian Herbert. If I just did it by the last name, is Brian Herbert guaranteed to come before Frank Herbert? No. So let's add on some more conditions. All right, so I'm going to compare their last name, but if that's a tie, if they're both the same last name, Herbert, then I'm going to say, then comparing book first name, get first name. All right, there we go. And this is becoming kind of long, so what you can do is you can go ahead and go down to the next line. What I generally like to do, though, is I like to align all the dots up so that you can read it much better. Comparing, then comparing, then comparing. All right? If you want to, what if they've got multiple books by Frank Herbert, all the Dune series, right? Then comparing, well, you can go another level deep here. Books, get rating or get year. There we go. That sounds good. All right. So all the Frank Herbert books will all be clustered together, but then they'll be in temporal order, the oldest books down to the newest books. Right? Okay. All you can chain that as many of them as you want, comparing, then comparing, then comparing, then comparing, until you get down to one final one where all ties are broken. In the case of books, what is a unique field here that we could use to break any tie? Can it be title? No, I was actually searching for a book the other day, A Stitch in Time, and there are like 5 books with that title, right? Book ID, right? That's guaranteed to be unique here, but I'm not going to bother with that. I'm just going to try to find Frank here, okay? Now I want to sort it, so collections.sort, books, and then by that author, CMP by author, right? And we can print that out, and you can see that it actually works. All the Frank Herbert books are together, all the Terry Pratchett books are together, whatever. But now I want to perform a binary search. Remember how we perform a binary search. It will, let's see, where did we do that? Down here, there we go. We perform a binary search on a collection with a key using the same comparator here. That will return an index. Either the index will be non-negative, in which case it was a successful search and we found it, or it's going to be negative, in which case it's a failure and we did not find that. Right? So it seems pretty straightforward enough. Int index is equal to collections dot binary search. There we go. And we're going to search books using what key? So key, question mark. And then you need to use the exact same comparator that you were using before. If I'm ordering it by year, but I'm searching for Frank Herbert, the author, then that's not going to work. Okay? So, and then if the index is greater than or equal to 0, we found it, right? There's a successful search, system.out.println books.getIndex. Right? Now remember that finds a book by Frank Herbert, not all of the books. Right? We'll do that next. Right? Else system.out.println no such book with that author. Right? And the line. There we go. All right. Now this is obviously not going to compile because I don't know what my key is here. All right. So what could be my key? Is an author a string, right? Herbert, comma, Frank, right? Well, and that I could put that into a variable here. Author is equal, and I'll even call it author key, right? There we go. And is that going to work? It doesn't compile, right? When you're searching and sorting for stuff, you need to compare apples to apples and oranges to oranges. That's not what I have right here. What am I searching? I am searching a collection of books. Right? That's what's called my haystack. And I want to search for the needle in the haystack. The haystack and the needle have to be the same thing. They have to be apples and apples or oranges and oranges. I can't go oranges and apples. And that's what I'm doing here. What is the key that I'm searching for? Is that a book? Nope. So that's why it's not compiling. If you're going to search a bunch of books, then you need a book as a key. Okay? Then you might ask yourself, well, wait a second. If I already have the book, why am I searching for it? Right? And this is what's called a dummy key. What I need to do is I need to create a dummy book record with the author, Frank Herbert. Right? And that's how I actually search for it. They've got to be apples and apples, books and books to compare. You can't search strings for books and books for strings, right? So what do I need to do? I need to create a dummy key here. Book B is, let's call it author book key. All right, there we go. Is equal to new book. And then I would go about providing the last name, first name. Well, what about all that other data? What about the book ID? Do I know the book ID? No. If I knew that, maybe I could look it up anyway. All I know is the last name and the first name here, right? Do I know the title? No, that's what I'm trying to find, right? But I would be forced, the way that I've designed this so far, to pass in zero, dummy key values for all of these things. 0 for the ID, Herbert for the last name, Frank for the first name, and then whatever else, nulls and zeros, et cetera, et cetera. I don't like typing like that. In fact, I don't care what the dummy key values are. I don't want to have to worry about that. So let me come back over to my book class here and extend its design a little bit, right? I want another constructor where I'm only responsible for the author's first name and the author's last name, okay? And to do that, I'm going to go ahead and rely on my IDE. Remember, go up to source, generate constructor using fields, and in this case, I don't want them all, right? Deselect them all. I just want the last name and the first name. Generate that one, right? Now, what about all the other values? Those take on default values of 0 or null or 0.0, right? And I don't have to worry about them because I'm not searching along them, right? So let's come back over here, and now I can go ahead and just worry about the last name. Was it last name, first name, or first name, last name? What did I do? It's last name first. Okay, so there we go, Herbert Frank. And then I can use that as my needle to search the haystack. Now it should work here because I do have several Frank Herbert books. There we go. Oh, no. Herbert, did I just misspell his name? I don't think I did. Let's find out. Fine. Maybe I don't have any Herbert. Nope, there's Herbert Frank. And let's come back over here to book demo. Maybe it's not working because of the year. So let's go ahead and get rid of that. I only want to search by the author. That's probably better. There we go. Yep, there we go. All right. Not even a Dune book there. The White Plague by Herbert Frank, 1982, score of 3.69. A little bit better than that, I'd say. Right? But I was able to find a book. Now, is that the only book in my collection here of Frank Herbert? Maybe it is Herbert. Nope, there's God, Dune of Emperor, God, Emperor of Dune. There's Heretics of Dune, Children of Dune, Dune Messiah, and Dune. So the 5 books in the Dune series. They're all in there too, right? What if I wanted to find them all, right? Binary search is only going to find the first needle that it finds, right? It's going to say, nope, there it is, here it is, or here it is, right? What I could do is I could take that index, right? There's my Frank Herbert book, and then I could go before that index and find all the ones that match Frank Herbert. I could go after that index and find the ones that match Frank Herbert, right? But what I want to do is something a bit more sophisticated, right? I want to answer this question. Who is the author whom I've read the most, right? So who, not what. Whom is the, they, them, who is the author, I think, right? Yes, there we go. Who is the author that I've read the most, okay? Now to do that, what I want to do is I want to solve this for all of the authors. I want to organize the data so that all authors, you can retrieve their books, right? So what was that arrow there? That's kind of reminiscent of data structure that we've looked at before, right? What kind of data structure did we look at? Where you can take one thing and then you can reference another thing. No? How about Pythoners coming from a Python background? What can you do? Like if you have a string and you want to map it to another piece of data, right? Those are called, in Python, those are called dictionaries, right? In Java, we call them maps, right? So let's use a map that maps an author to a book, or to a list of books. Now, before we do that, do I have a concept of an author yet? Right? I have a concept of a book. In other words, I have a class that represents a book. But now I need to go back to my to-do here. Last name, first name. That seems like 2 pieces of data. And anytime that you find yourself having 2 or more pieces of data, right, then what should you do? You should define that as a class. Okay? So let me come over here, and what is an author? Let me go ahead and right-click this, new. More generally, what is an author? I could call it author if I wanted to, but what if they're an editor? What if they are a director of a movie instead of books? What if they're both? Right? We'll talk about that when we use object-oriented programming. So what is an author? A person. Right? It's not persons. We don't pluralize classes. It is a person. Right? All right, what is a person? Well, for us, for now, all I need is a first name, last name. If we need more data, we can come back and add that data later on and refactor this and change it. Now we need a phone number. Now we need an address. Now we need an email, right? But for now, I'm just going to go private string last name and private string first name. Making a class is not at all hard. Right? Once you've got your data here, all you have to do, remember, is go up to source, generate constructor using fields. In this case, I want both of them. Let's go ahead and generate that. Great, I didn't have to type a single line of code after those first 2 lines. I also want, what else would I want? Source, generate getters and setters if you want. I'm only going to do getters, right? So you can get the first name and the last name if you want. And then finally, I'm also going to generate a toString method here, right? Based on the last name and the first name. Now, unfortunately, there's the default behavior there. I don't like that. I'm going to change this so that it's last name, comma, plus first name. Right? But the code editor got me 90% there, right? Without having to type too much. Okay? Now that I've got the person, first of all, make sure that everything's nicely formatted. This was Shift-Command-F. I don't know what it is on Windows, but reformat it. And also, what else do you need? Documentation. Represents a person, right? That's all you need. Now, if this were the main class with a main in it, then you would also need an author documentation here, but that's good enough. Now we can come over to my book class and we can refactor. What we can do is we can redesign this. Instead of a last name, first name, I will say that it's a private person, author. Okay? That's so much simpler because now I'm dealing with a person like an object, right? That has a first name and a last name. Now, this needs to be fixed. I can no longer take the first name and the last name. Instead, I need the person, author. Person, author. Right? And I can say this dot author is equal to author. There we go. Good. I also need to change this because I'm no longer taking a last name and a first name as separate strings anymore. I need to change that to person, author. Right? But it starts to shorten up a lot of stuff. This dot author is equal to author. Get rid of those 2 lines. I've collapsed at least 2 lines down to one line. What about this, where I was separating the first name and the last name? I don't need to do that anymore. All I need to do is rely on the class to do it for me. This dot author. Right? It'll automatically call the toString method that I wrote in the author class and take care of that for me. Right? What else needs to be changed? Well, getters. And once again, you can just go ahead and get rid of them. And if you want to, you can go ahead and rely on your editor here. Source, generate getters. All of them are already, I can't check all of them because they're already there. But author is not there, so I'll just go ahead and generate it. There we go. Oh, I didn't mean to do the setter, so let's go ahead and get rid of that. Okay. But otherwise there, it compiles and it's been redeveloped, it's been redesigned here to be a little bit better. Of course, that means all the code that depends on that has to be changed because I can no longer have a last name and a first name. I need to create now an author. So person, author is equal to new person with the last name, comma, first name. There we go. And down here, I will change this to author. Okay. So anywhere that I'm redesigning this, of course, it needs to be changed, but it's going to be a lot easier at the end of the day. Right? Now, I do need to change Frank Herbert here because it's going to be get author. I can no longer do the last name and first name, but this is going to lead to a problem. Right? Okay, there we go. Comparing get author. Right? So let me just go think like the Java compiler here. And if you went to the person class, you'd see this and you'd say, oh, okay, person class. How do I compare one person to another person? Well, we know how to do that. If they have the same last name and the same first name, at least as far as this design goes, then they're the same person. Alan comes before Zoe, with respect to last names, right? We know how to order those, but is there any piece of code here that says this is how you order a person, order 2 people? Nope. So here's another way of imposing ordering on your data in Java. What I'm going to do is make this comparable. Implements, got to spell it right, comparable person. Now what this is doing is it's saying this person is now comparable to another person. You got to spell it right. Comparable, there we go. Right? There, oh, it was, you don't have to import anything here. You'll find that this is how it's actually done in all of Java. Strings, doubles, integers, all those things that we got for free, we didn't actually get them for free. Somebody came along and wrote code to make them comparable. It was just part of the Java language that somebody already did that. Now because I've created my own class, I need to do the same thing. Now to do that, you have this method called compareTo, which we've seen before when we were looking at strings. Right? So we're going to take 2 people here, this and that. Right? I don't not this, but that. Right? So this object right here is going to take that object and it's going to compare them. Right? So if this dot last name equals that dot last name, right, then I need to look to the first name. Is this how I do string comparisons though in Java? Nope. Is that how I do string comparisons in C? Definitely not. That is unfortunately how I do string comparisons in Python because that's how Python works. Right? But that's not how I do it here. Right? What do I need to do to compare these 2 things? I need to know if they're equal or not, right? So dot equals, but that would only tell me that they're equal. It wouldn't say that Herbert comes before Pratchett, right? That's right? H before P, right? That I need more information than just whether or not they're equal or not, right? So let me go ahead and back up, right? And let's go ahead and create a result here. This is the same, an integer result. This is the same pattern as before. You return something negative, positive, or 0, depending on the relative ordering of things, right? Well, remember that we're trying to get a result with respect to the last name. So I'll take this person's last name, and I will compare it to that person's last name. Oops, last name. There we go. Now, if they're equal, then this will return 0. There we go. And we then need to look at the first name, right? I'm comparing last name to last name. If they're not equal, then I'm done, right? Herbert comes before Pratchett, and you're done. Or Pratchett comes after Herbert, equally. Otherwise, if the result is 0, then we need to break a tie. Break the tie, looking at the first name, right? And so here, the result will be reset to this dot first name dot compare to that dot first name. There we go. And at that point, now I've broken ties. Return result. All right. There is no other data to look at here. If I had a social security number, maybe. If I had an email, maybe I could break ties that way. And that Frank Herbert is not the same thing as that Frank Herbert, but whatever. Right? This is all we can do because this is all the data that we have, first name and last name. Okay? That makes it comparable. Now, over here in the book demo, that compiler error has now gone away. Because authors are people, and people are now comparable because I wrote that code over in that other class, right? So that code will still work. Let's clean this up a little bit. I did this and that so you would realize the difference between this object and the object that was passed in when this function was called, right? This and that. That is not a great variable name, right? So what I'll do is I'll refactor, rename. What would be a better variable name here? P for person, or you can say person, right? That's why we use upper camel casing conventions and lower camel casing conventions, so that when you see a lowercase variable name, lowercase, you'll know that that's a variable. When you see uppercase, you'll know that that's a class, right? All right, there, that's better. Did you remember that IDE trick? If you ever need to rename a variable, right-click, refactor, rename, and it'll rename it everywhere for you. Okay? Finally, get rid of the cruft. I will leave this in here when I post this to the notes, just as a reminder of why we're doing this. But you do not leave code or comments like that in your code. That's cruft. That's clutter that needs to be removed. Okay? I'll leave it in there, though, for you. All right. Okay? How does my searching now change? Right? Well, now I need a book, not with Frank Herbert, but with new person Frank Herbert, comma Frank. And there we go. All right, I just needed to fix that. And we've broken nothing, by the way, right? Let's go ahead and run this, right? It still works. There's the White Plague by Frank Herbert, right? But now because I redesigned it, I invested a little bit of time up front to design my classes correctly. Now it's going to be a whole hell of a lot easier. I can create a map that maps an author to a list of books, right? And I'll call it book map, right? Is equal to new hash map, right? There, and now once I've imported everything, it should compile. Let's go ahead and import that. Let's go ahead and import map first, and then it will import. I shouldn't have to import author since it's in the same class, right? Oh, it's not author. What is it? It's the person class. It represents an author, but it's a person. So it's an author mapping to a list of books. All right. Now all I have to do is for each book, right, add it to the map, dot. Okay. But I'm going to outline this a little bit for you, right? So for each book, add it to the map. So for each book, If the person is mapped, then just add it to the list. Right? If the person is not mapped, right? In other words, this is the first time we've seen this author, right? Then we need to create a new list. So create a new list and map it to the, and add it to the list, and add the book to the list. Right? This is a whole lot better way of thinking about the data. Before it was just a generic list. Here's a bunch of books. Right? If we made it into a set, it would be what we call a bag of books. Here's all the books, right? There's no order here at all, right? But up here, we've imposed an order by first sorting it by rating, then by year. Then we searched it by sorting it by author. What I'm going to do now is I'm going to actually change it so that I'm no longer organizing it just as a dumb list that can be ordered one way or another. Instead, I'm going to have an entire map. This person maps to that book over there, right? All right, so we can do part of this outline. We're not going to get it done today. We'll save that for Friday. But for book B in the collection books, there's my for each book, right? Okay. And I'll end it down there. Right. Now, if the person is mapped, right? B dot, or I guess a book map dot has key, I think it is, or what is it? Dot contains key, there it is, contains key. And here it's going to be the person. I'll leave it at that for now, right? If it contains the key, then we can go ahead and put it into the list, right? But what I'm going to do is I'm going to actually make this a little bit simpler. I'm going to go ahead and get the list of books. Books by author, by that author. That author. B's author. Is that better? All right, so there's an old saying in computer science, there are only two difficult things. One of them is cache invalidation, and the other is naming things. So what would I call this? This is the author's books, right? So let's actually get the author first so that you know what I'm talking about here. Person author is equal to b.getAuthor. There's the author, right? And maybe it's better now that I call it books by that author, Right? What would you want to call it? That's good enough. Move on. Don't spend too much time thinking about better variable names, right? At the expense of actually getting things done. Bookmap dot get and then author. There. That gives me a list of all the books by that particular author of this particular book, right? Now, if this is the first time that we've seen this, have I created that list ever before? No. So that list will be null. If books by that author is null, then that means that this is the first time we've seen author, right? ... So the list doesn't exist and it's null. If I try to add something to a null list, what do you think is going to happen? Can you add something to something that doesn't exist? Nope. So what should I do? I should create that list. Books by that author. Let me go ahead and make it into a new array list. Right, there we go. Okay. Now, all I have to do is add the book to the list. ... At this point, I know that it's not null, because if it were null, I created that list right here. Right? So books by that author, let's just add it, add book. Books, the book is B, sorry, B. There we go. All right. That's correct. And then we need to put it back in there. Yeah, we need to put it back in there. Book map. How do I put things into a map? Do we remember? I can get them using the key, but when I put them in, I need the key and the value. So put, right? And that's going to be the author maps to books by that author. Right? There. Okay. Now at the end, we'll continue this on Friday, but let's just go ahead and print it out to see what I'm talking about here. Print out ln book map. Right? I don't know that it's going to be all that nicely printed. Nah, it's all going to be one big giant line here. But here we go. At the beginning, we have Octavia Butler. She wrote Kindred and anything else? Nope. Wind in the Willows, Oquilifor, Yeah, I'm not going to get many there. Instead, we're going to have to write code to print the result in a nicely formatted manner. Dot, dot, dot. If you're coming from a Python background, you wouldn't have to do too much work. There's this library called pprint. P stands for, not nice, but pretty format. Pretty formatting. It's called pprint because it's pretty format, pretty printing format. You'll encounter that actually in your next assignment 1.0, when you output stuff to XML and JSON. It's not going to look nice because computers don't care about white space. But when you print it out, you want it to look nice, and so you will pretty print it. And we'll pick it up there on Friday.